actually add a project to the folder. Emphasis on folder, solution project. So depending on how you start your .NET projects, this may be super familiar or a little confusing to you. But basically, I've just opened the folder and then I'm going to put projects in the folder. But there's no solution file per se that's having them assigned to it. You can set up a project that way too, but I'm doing it this way. I'll probably do another one subsequently the other way just for reference. But this one, I'm going to do this way and a test project inside of the folder that we're. So I'm going to call this binary tree things test. So there are multiple of them. The first thing we want to test is just if we're passed in a null tree, basically an empty tree, right? So that'll be our first test. And I'm going to go ahead and grab this one, hijack it, call it, let's hear, max sum in null tree over. All right. And then we'll call our tree, our binary tree object, we'll just call it tree node and root, and we'll start with a null one. So null will return. So we know assert r equals 0, and we'll call our object that will have the max sum function method thing on it. We'll call that climber. We'll just make that like a static class probably. We'll call it max sum, and you'll notice that there is no climber and there is no tree node objects yet. So I'm just typing this in, kind of making it up as I go, and then I'm going to have the IDE help me build these things. Let's go ahead and create an ignore file too. We use all the .NET things. Pick all of them like this. And then since I'm on a Mac, I always go and just go ahead and add ds store, which is a Mac file, and then the IDEA directory, even though I think that's added somewhere down here, but whatever, I like to make sure that I add it myself right at the top to make sure those two. They're out of there. I'll go ahead and hit on that. Things should be good. And then this should just break because it's not even going to build, right? There's classes. But if I use the writer / resharper type of thing here to refactor it and create that type, I'm going to create it as a class, and then we'll create that as static class to that. And then here, let's see, split variable. No, I don't want to do that. Let's go create climber. Climber will also type, and it will also be static. And then within that, we want this method, create method climber.maxSum. And for now, that looks perfect. Okay, so now this, let's see, is this give me, oh, whoops, that up. I think this will give me at least a build. Tree node static type. Oh, yeah, let's do. Yeah, I can. I know. Oops. This. We'll come back for that. Well, let's get a build up. Root. And to pass, it should just return 0. That'll at least pass our test. Here. Okay, let's not make it static. And that should give us my C# knowledge is failing. If I run it, oh, yeah, so if I ran it a second time, and there we go, success. Okay, so I just had to build it twice. Something about, I think like just some something about the build wasn't done processing that, so it wasn't quite ready to. So anyway, this succeeds. I get a 0 back. Of course, it doesn't really perform the function. What I'm really wanting to do is something like if root do this, if root equals null, then return 0. Else it's going to do whatever else we process. And here it's going to, let's do 1 for right now. Otherwise this would be the sum. Calculate the sum here. But this gives us enough, and it gives us a passing test, right? So everything runs, yep, pass. So now take this and let's put this in. Let's see, I want to refactor it. Use a refactor to put it in a file of it. This, let's move to another file. Perfect. Repo. It to move it to another file. We got that here too. The tree node, boom. So those pieces are there, and now we can go add a class library. I'm gonna call this the tree node. So take this and actually just drag them into here. So get that refactor. I'm going to delete this. Delete. Go back over here. Space. This. So everything lines back up there. Now this is red because it's off in another project, but since Rider keeps track of these things, it will let me instantly reference project tree node, the new project. So now it is in its respective class library, and I am now working test project space, right? So this test is basically, if we write out what the example looks like from a tree perspective, it's basically this, right? But let's put up another little tree example like this one. We will, let's see, we're going to start with 5. We'll bounce out to the next 2, which will be, let's do -22 and 11. That sounds like some fancy numbers. Out a little further, got to make it look good, right? So there we go, and then that goes down to the 2 numbers. Perfect. Let's move it out. Okay, and then here we're going to do boom, boom. So these need to go out. Then let's do another level. We'll do 9, 50, and then, I don't know, 9, 2. Picking some numbers here to work with. All right, so that's our little binary tree that I've just conjured up from nothing. We'll use that for our next example here, and we'll write another test. We'll call this max sum in perfect tree. So let's hear tree node left equals tree node. Let's hear, how would we do this? So we do leaf then with leaves. I think actually let's bomb out of this and not follow TDD for a little bit and try to actually write out the tree node class. Okay, so what we're going to need here is, so I have the tree node class already, and then let's see, we're definitely going to have our recursive bits, so we'll have a public tree node in the tree node, right? And we'll do left and right for each of the leaves of tree, the binary tree. And then we'll want to do let's do a constructor. So yeah, previous warning was you can't pass in a static. We don't actually want a static for this one. We want a static for the climber maxsum method. But for this one, we'll want to do your tree node and then pass in value tree node left. We'll do this, default it out to null when you don't pass this in. I think that'll be a good construct. So we pass in a value, and then we say that it needs to be on the left or the right of the tree node, which we can then instantiate and create. Like, let's say we got this value, and then we got this dot left, and then this dot right. It's right. Yeah, so I need a public. So this would be an int. What is going on? What did I do? Value. There we go. Yep, that looks. So there's the private param, and then the passed in params constructor, and then we'll want to. I wonder if I can just generate code for this stuff. Properties. Yeah, let's do each one. And then we'll hit OK. Boom, yeah. Okay, we got that. So value is value. I have not used that syntax before, but hey, whatever works. So left and right. I might change that just because I'm not super. Anyway, let's see. We'll also want the nested thing. So we'll do a public static tree node leaf int. Can I do that? Let's see. All right. So we're going to do return tree node and value. So that'll particular tree node with the value. Yeah. Okay, that should do that. So that'll give us the left one to do. We want to do, I mean, the leaf. It'll give us the leaf. Did I spell left? Yeah. Oh, yeah. Let's say leaf. And then that'll return the value of whatever the leaf is, whether it's left or right. Okay. So then, let's see here. What do we want to do? We got left and right. Let's do a. It's clearly been more than a hot minute since I've done. Why is value? Why did I? Oh, whoops, value. Oh, yeah, I was trying to use the local. Whoa. Yeah, maybe I should read. No. That's fine. Let's leave it. Then we want to do public tree node with leaves. Do int left value, int right value. And then we're going to want to do one for each of the others. So public tree node with left leaf. Yeah, leaf. And we'll do int left value. And then public tree node. Damn it, I keep hitting weird buttons. With right leaf. Int. All right. And then we're going to want to, what am I missing? I'm missing something. I believe, oh yeah, we need a join. Public static joined one. We say int value and then tree node left and tree node right. Right? Yeah, that looks good. And I'm going to actually, I need those properties. I do need these functions. So, and this is tree node, and then this with leave, this left equals new tree node with left value right equals new tree node with right value. How do I keep getting my casing? Let's refactor this and get the casing. Derp. Right value. There we go. It looks like I'm paying attention to what I'm doing and not sloppy. So then we want to return this. We need this. Yeah, that makes sense. So then with left leaf just going to be this dot left, and that's going to be new tree node with value. Did I case it wrong too? Am I actually doing this, or there we go. Whatever, maybe I am doing this. Seems like I either fat fingered or it auto corrected it wrong in the first place. Anyway, this right is new tree node, and same thing, right value. Turn this. So that's going to get us our leaves or whatnot. And then for this one, the join would be return new tree node with value. So this is the whole kit and caboodle, right? Left and right. That'll give us like that. So we can then walk through the tree and get the values we need and start summing them. Because since we're just looking for the max sum, we can just go through single pass and boop, 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 add them up and get our total. So I think with that, let's do a little cleanup here. Remove, let's see. And then, yeah, these are grayed out. If you're looking at the IDE things, they're grayed out just because we haven't used them in the code base. Convert into constructor. Whoa, wait. Oh, wow. You can do that now? That's a new C# syntax. Let's roll with that. Let's roll with that one. It's kind of weird to me. Did it leaf just literally took that and it puts it on the no. It puts the defaults up. And then and it does the assignments here. Like left. So anyway, that's so not part of this problem, but hey, syntax sugar. We'll try that out, go back over to tests, and all right, let's write our next test. So we got our null one, and we're going to go with this randomness that I just conjured up here. Tree node to the left, we'll build out the tree, right? So tree node dot leaf. Start with -22, and then with leaves 9 and 50. Yeah, 9 to 50. Tree node right. Tree node dot leaf 11 with leaves, and we have 9 and 2. And then we got tree node root equals tree node join the top one 5. It's the root of the tree, and then we'll add our left branches and our right branches for a nice balanced tree here. All right, now let's hear assert dot equal. What would be our so this is 16 2 minus 33, and then, oh yeah, so it'd be 33, right? 34, 33, 33 climber in the root for the whole thing, and now it should get 33. Of course, if we had sum, but we should run this, should get, boom, expected 23 and failed. So let's go back to Climber and let's start tackling something right in the else here. Right, so first thing I'm actually going to do is let's just do a gated if here and say something root. I already have it right there, but root equals null, return 0, and that can just be a one-line thing. We can nix this bit, and then let's say int max equals int dot max. I think that might be. And let's hold on a second. Let's go with, we'll write an internal one that'll say private static void, and I'm just going to put some other process. So we'll do find max sum, and then we'll do the tree node, the node, int current sum ref max sum. Okay, and then in that, so if node equals null, just to gate it here too, return. I don't like writing it that way, but that's what I'm going with for the moment. We'll get our current sum, which will be plus equal the node value so if then the node, oops, the left node is null and node dot right equal to null, then we can pop out and say if current sum is greater than max sum, do max sum think. I feel like I'm trying to go through. So then we're going to recursively do find max sum to go down the tree. We'll say node dot left, the current sum, and ref. Is that going to work? I think that's going to work. And then we'll do one the right side. So we check both sides of the tree, right? So then I'm going to call that. So I'll need to do a max sum. Yeah, I was right. Okay, so int dot value. And then find max. Right here is the initiation call. It's in 0 starting and ref sum. And that to do that can return, right? Yeah, max sum. So if that's return 0, otherwise some min value and pass it into the recursive method here, which will take the ref of max sum for reference, and then current sum is 0, and then it begins its recursiveness, which it should recurse through itself the number of times that it needs to per the particular tree of the binary tree, or the leaf of the binary tree, and then it should drop back out once it gets the current max sum of the tree. That should work. Okay, so with that, let's go back over and see if my little test here is still red. So it should get 33. Should get 33. What happened? Well, okay, so that worked, but this one didn't. Oh, because I just ran one of them? Is that what the problem is? Yep, that's what it was. Okay, I just ran the one test, so the one test. Okay, so that's cool. All right, let's do another test just to see where we can get here. I don't like to not have lots of test options, right? So let's write 2 more tests. I'm going to use Magic Video, and then we'll dive right back into basically refactoring them. So you're going to blink, and here's the tests. So as promised, a whole bunch more tests. I have one here for mass sum in all negative values trees. I got one that's just one number, so you just get the root node, and that's it. There's no leaves. I got one here for max sum in 0 value tree. So 0, 1, 0, 0, 0, 0, and that can throw a curveball in there if I haven't written the method right. And then I got a negative 10, 9, 20, 15 seconds, so it's 15 and 7. So it's kind of a, it's an unbalanced tree. And then we one that just goes down one side, so it's almost a list versus a tree. Anyway, blah, 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 blah. I have these other tests in here that should cover a number of examples. So if I go over here, and I should get them all to pass, and they do. So now I can get into a refactor. Let's do it. All right, so what I'm going to actually do here is I'm going to just take this, and I'm going to comment out it. And let's see here for the, all right, so for the next bits, I'm going to use some things. I've been thinking about this as I type this, and I realized I could probably just use some like link statements and things like that to really simplify things. And I have an idea, and I'm going to try to code it out right now. Hopefully it doesn't implode on me, but basically I'm going to use a little bit of, I'm going to use like a switch expression, initiate with that, and then try to do init only. Well, I already did init only properties. We use a max. We use some of the built-in methods or method, and then lambda expressions. And yeah, I think that will actually clean up our code a good bit. So I'm going to use those things. And like I said, this might implode, but hopefully I'm thinking it through right, and what I'm about to show you is going to be really, really cool and work really, really well. So let's cross all the fingers and hope that that's how it goes. So with that, I have commented out my code, as you can see right here. And then what I'm going to do is just do a whole return lambdaized switch method. So we'll do return root switch like that. And then let's see, the first one, of course, is give me my null that's going to give me a 0, right? So that returns 0 if it's null. However, if it's, let's see here, left is null, and then right is null, then the value is var_v, and that'll, yeah, just run the v. So that'll be that. So like if it's basically if it's one value, kind of that's the deal there. And then we got a left null. Then we're going to do right var_v. Wait, no, we want to give it its own thing. Let's go with var_r for that. And then value v. And that should be v plus max sum right. Yeah, okay. And then we want to do left is not null. We'll do var l. And then right is null. And then what are we doing? Oh yeah, value var_v. And that should be v plus, what's wrong with the other one? Oh, I didn't get a, there we go, var_v plus max sum left. And now the last one should be all the bits. So left, var left. No, it doesn't want me to, Oh, I just have to complete it. Okay, right, var right, and then value is v, var v. Do I have to put the, I guess I do have to put the vars or whatever. It almost seems like you could take those out, you know. But yeah, v plus, and then this one is where I need to do, I think it's system, come on, system dot maths, oh, math, max sum, or maybe max returns the larger of two native signed ints. Yeah. Okay, that'll work. So max sum L, max, we'll come back here. Yeah, max sum right. And that's the end of my switches. And okay, that should be right. That should be right. So I took care of the left, took care of the right, took care of both, took care of null, and took care of root and having nulls. So that should take care of all of them. So I'm going to go with that, and we'll see if I am competent enough to have done that. So run all these puppies again. Wow, okay. It's almost like startling that it does it so fast, and it worked. So that bit of code works. That replaces all of this mumbo jumbo into some clean lambda linkish type of statements. So I guess I could completely remove this now, and I can completely remove this. And can I refactor that anymore? I think that's about it. What is this fussing about? Move to tree node namespace. Yeah, sure, let's do that. Tree node, put it in tree node. Yeah, that looks like my max sum method refactor. That's mean, lean and mean. Okay, so with that, I'm just going to go with it as is for this. Let's see if what we can do. This make field read only. Rename to value with the, oh, I don't really want to do that. That's some, yeah, I guess since it's public, the public property would be uppercase. That's the syntax method to use with .NET. So I'll go ahead and do that. Rename to value. Doesn't really need to be read-only. But is it in a position to do that? Well, we'll do read-only then, because it should compile a little better for some, you know, whatever reason. And what is this saying? Change type parameter left to tree node question mark. Oh, to say like make nullable. Should I make it nullable? Like that. Okay, yeah, that seems right. So we got no more crazy dinks in there. With right leaf, with left leaf, with leaves. Why is this not used anymore? I wonder if I completely messed something up just now. Move to, let's put that in tree node 2. I'm gonna go back to my tests, and we're gonna see what we broke, if we broke anything. No, it works, okay. Leaf with leaves. What is this fussing about? Any other refactor here? Transform to constraint. Yeah, let's go with constraint model. So constraint model, basically you put this over here, and then you put the variant bit over here, or the, you know, the known and the limiter constraint over here. So, and then it wants to do that to every one of them. So I'll go ahead and let it have its way. And anyway, I'll go through that. I'm going to commit this code, and you're going to have it. I got a blog entry linked in the description that goes through all this, so you can have this, the syntax to copy and paste however you want, and a walkthrough that's written out instead of just this verbal one. So anyway, I hope you have enjoyed going through this with me. And in the very near video future present, the next step is I'm going to be taking this and another couple dozen of these problems that I'm solving, and we'll go through them and test out AI to see what AI comes with instead of just my thinker up here, because, you know, I'm always curious what the artificial thinkers are doing out there. With that, happy thrashing code, and I will catch you next video with some more code slinging and some AI processing. Cheerio.